We're all seeing it. AI is just exploding, right? But what if I told you that behind all the incredible software and algorithms, there's a hard, physical limit that we're about to slam into? Today, we are digging into the AI energy playbook, and it's all about the real-world, physical constraints that are going to define the future of AI. And it really all boils down to one powerful idea.
And this quote just nails it. You know, for all the chatter about bigger models and faster chips, the real bottleneck for this next wave of AI is not software, it's not silicon, it's just raw physical power. The companies that figure out how to get, manage, and use energy efficiently, they're the ones who are going to win. It's as simple as that.
So, just how big of a deal are we talking about? Well, get a load of this number. By 2030, projections show that AI data centers could be chewing through 1,000 terawatt-hours of electricity a year. Now, to put that into perspective, that's more power than entire countries like Germany or Japan use in a whole year. This isn't just a little bump. This is a massive, fundamental shift in what the world needs from its power grids.
And that leads us right into our first big section, AI's hidden energy problem. See, we have to stop thinking about energy as just another line item on a spreadsheet. It's not just a cost. It's now the primary scarce resource that is going to dictate how fast and how far AI can actually go. And listen, this is not some 10-year-out sci-fi problem. We're talking about the next 1,000 days. That's less than 3 years from now. The ability for anyone to scale their AI ambitions is going to come down to three very real-world things. Can you get the megawatts of power? Can you get a spot in the line to connect to the grid, a line that's already years long? And can you physically cool these incredibly hot, dense machines?
So if that's the new reality, how in the world do you build for it? Well, let's take a look inside what we should start calling the AI factory. And trust me, this is not your parents' data center. The engineering, the economics, the whole game has changed to handle what AI demands.
For years, the gold standard for measuring how efficient a data center is has been PUE, power usage effectiveness. It's a simple ratio. How much power is going to the actual computers versus everything else, like the lights, and most importantly, the cooling. A perfect score is a 1.0, and the best of the best are shooting for 1.15 or even lower. It's a super important metric, but, as we're about to see, it's just not enough anymore. In this slide, this shows you the huge physical shift that's happening. Old-school data centers just used massive air conditioners to cool everything, but a single modern AI rack can pull down 80, even 120 kilowatts of power. I mean, that's like stuffing a dozen high-powered ovens into a tiny closet. Air just can't keep up. It's like trying to cool a blast furnace with a desk fan. So the new standard, the only way forward, is liquid cooling. It's way more efficient, and it is now the default design for any serious AI factory. All this insane energy consumption forces us to ask a brand new question. Okay, we know how to measure the efficiency of the building with PUE, but how do we measure the actual value we're getting from all that power we're pouring in? It's time we defined a completely new unit for AI. Let's really pause on this for a second. Your facility could have a world-class, super low PUE, amazing. But what if the AI models running inside are just wasteful, spinning their wheels, burning electricity to produce useless results? Does that shiny PUE number actually mean anything? No, of course not. We've got to connect the energy we're using directly to something the business actually cares about. And here it is. This is the big idea. A new metric called ECI, or Energy Per Verified Outcome. Instead of just measuring the kilowatt hours going in, ECI measures the kilowatt hours it takes to get one valuable result out. That could be a customer support ticket that gets resolved, a protein that gets folded correctly, or a financial trade that gets executed. It finally links the energy bill to actual business value. It gets everyone, from the engineers to the product managers, speaking the same language.
The key, though, is to make this something you can actually act on. So a fantastic goal for any organization to set right now is this. Aim for at least a 15% improvement year over year in ECI for your biggest AI services. A target like that forces the whole team to get smarter about everything, which models you choose, how you run your code, everything.
Okay, so we get the problem. It's huge, and we've got a new metric, ECI, to measure what matters. But how do we actually put this all together into a winning strategy? That's where the AI Energy Playbook comes in. This is the strategic guide for these next critical 1,000 days. The whole strategy really comes down to three common sense pillars. First is siting. Where you build your AI factory is everything. You have to focus on the reality of the local power grid. I mean, think about it. You could try to build in a place where the grid is already strained and it'll take you 5 years to connect. Or you could build right next to a new offshore wind farm and get a direct line to clean, reliable power. One plan is dead on arrival, the other scales. Second, procurement, how you buy your power. And third, operations, when you decide to run your AI jobs to be as smart as possible.
And this is what a truly modern energy portfolio looks like. It's not good enough anymore to just buy some renewable energy credits at the end of the year to say you're 100% renewable. The new goal is 24/7 carbon-free energy, or CFE. That means matching your energy use with clean power, every single hour of every day. And yeah, the core of that is going to be wind and solar. But you absolutely have to back it up with firming power, things like nuclear or massive battery storage that work when the sun isn't shining and the wind isn't blowing.
From an operations perspective, it means you have to make your AI workloads a good citizen on the power grid. You can use smart software that automatically runs training jobs in the middle of the day when solar power is cheap and abundant. Or it can route tasks to a different data center in a different time zone where the grid is cleaner. The big idea is to turn your AI compute from this giant, inflexible power hog into a flexible, valuable asset that actually helps stabilize the whole energy system.
Now, you can have the best strategy in the world, but it's totally useless if nobody owns it. And that brings us to the last and maybe most important piece of this puzzle: governance. In this new world, who in your company is actually responsible for owning the energy switch?
And the answer has to be everybody at the top. This cannot live in some small sustainability department. It has to be a C-suite priority. You can see it here. The CTO owns the efficiency of the models, that ECI metric. The CFO owns the big power contracts. The COO owns the physical data center's performance. And the Chief Sustainability Officer owns the carbon accounting. When everyone has a piece of the pie, the whole thing actually works.
So really, if you're an executive or a board member, the single biggest mindset shift is this. You have to stop treating energy and computing like it's the water bill, some back office utility you just pay. It is now a core strategic asset, just as important as your talent or your intellectual property. It is absolutely central to your ability to compete.
And the best part is you can start moving on this, like, tomorrow. This timeline here lays out a concrete 12-month plan. In the first 90 days, you adopt that ECI metric and you start measuring your hourly carbon footprint. Within a year, you should be cutting the ribbon on new liquid-cooled hardware and signing the deals for that firm, clean power. It's aggressive for sure, but it is absolutely doable.
And finally, think of these as your go/no-go safety checks. Before you go and pour hundreds of millions of dollars into scaling up AI at any location, you have to hit these thresholds. They're your risk controls. Is the building efficient enough? Is your clean energy supply reliable around the clock? Do you have enough firm power to ride through any situation? If you can't say a confident yes to all three, you are simply not ready to scale there.
Which really just leaves us with this one final thought. In the AI economy that's coming, your biggest constraint, the thing that will hold you back the most, isn't going to be your code, it's not your talent, it's going to be your access to power. And so the real question you need to take back to your organization is pretty simple. Are you ready for that?